This is 80 and 60. Is this goes all the way to
Yes,
under C?
It's straight under C.
So another 40 distance. Another 40 the distance times W3. If you can get these together, you get what is L. The W has to deal with, so this is how you should think about it. Agree on how we should look at it? Now, if I want to go and call member AB, member BC, and member CD, what is the L? This is 80. BC is 80. What about AB? The square root of 80 squared plus 60 squared, correct? Which equal 100. This is AB. This is L. Okay? Now, we said, and again, this is another question, in the midterm on Monday, you should show me the axis where you measure. Where I should put the axis in this case, because I don't care about the y-axis, I care about the x-axis. This is the y, the most important axis that we need to worry about. The x-axis has nothing to do. I want it with x-axis, I want it horizontal. So in this case, this one is going to be the xi is going to be 80 over 2. 40 for AB, 40 for this, L over 2. Agree? Then if I want to go xi, li, because this is the li, you get the numbers here. 4,000 here. Yes. This is 0,032. This is L squared over 2, and so on, if you want to deal with it like this. Total here is 180 plus L. What do you want to do in this case? You want the center of gravity to hit on C. You don't want to be heavier than the other, correct? So that's all you need is center of gravity equal 0. If you want to go with this, so x bar is going to be this number here, 7200 plus L squared over 2. All over 180 plus L. Okay? And this is equal 0. Agree? If this is equal 0, then you can solve it. L with L will cancel each other and divide it to get the other L. What is L? So you have one equation here with one L. That is a way to solve it by using the centroids of the length. However, if you want to solve it by the moment from here, and you want the moment to be 0, not one to grab more than the other, okay? In this case, you will write here one equation with one unknown, L. This in here. Because the W Read the question. It is the same all the way, the same thickness. So the W for this portion here, this is 80. 80 times, let's say that it is 5 pounds per foot. 5 pounds per foot. For example, you multiply 5 pounds per foot here, 5 pounds per foot, 5 pounds per foot here. It's the same. Remove it. G is 32.2. You multiply it here and here and here. Agree? It's just like the density. So the W equal M times G. Correct? The M is what? The rho, the density, times what? The volume. We don't need to worry about the volume. We worry about the length. Correct? So the G and the rho are going to be the same for each one. In this case, you can, through the moment, find that the moment at that point is 0. And in this case, you can find it. So either you use this method or this method, you should be able to find the length of L to make it the same. Okay, I hope I answered your question. Let's look here where I put the when we talk generally, just to put you on the picture, we said that total W or total A equals summation of AI. Agree on this? Total A, I divide this table into 6, 7 portions. If I add them together, I get the total of the area, correct? W is the same, sum of WI. So if I have a jar, in it I have 10 pieces of chocolate that weight 1 pound. I look at your chocolate here. So this is what is going to be. Add them together, you should get the 1 pound. Each one piece, whatever it is. Make sense? So these are the W. When we deal with agree on this statement, generally, when we deal with the integration to get any W or any A, agree? That's general integration basics thing that we deal with. Now, if I have here XA, XB, YA, YDA. Do you agree on these? This could be X and Y bars, which it is representing the integration. In this case, from this equation, X bar is going to be the integration of XDA over A, or sum of AI. If I go here, the Y bar, integration YDA over A. I think your book called this QY and this QX. Check please where I put my book. I think your book called them QY and QX.
Yeah.
And QY and the QS I have no idea why we need a new name. This is the equation and simple. Our equation, used to be, where I put it? We have it somewhere. Sum of xi ai over sum of ai. This equals that using the integration system. So Q, let me see what does the Q says. Q. The QY, first moment of area with respect to y-axis. First moment of area with respect to y-axis. This is first moment of area with respect to x-axis. And in this case, we get the x through this way or x through this way to get you. Now, if I say the QY equal x bar A, or x bar A equal the QY over A. This is a third way to work with it. This one here, using first moment of area. Later on, next year maybe, you might, it depends on your school, you might get to learn more about first moment of area. We will talk about first moment of area in chapter 8 a little bit, but if you go through it later on, you might be able to find the x by that. But all you need to think about is, this is the main idea here, this one here, with this one here, and finally, you might get it through this one in here. Any of these three will help you find out the first moment of area.